This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 2, Lesson 5, Collections. The Swift language has three built-in collection types: arrays, dictionaries, and sets. This slide deck will cover arrays and dictionaries. An array is defined using square brackets, and then you have a list of values separated by commas. Here, we're creating a variable array called names. It is an array of strings, and we're using an array literal to initialize the array. So in this case, our literal has three string literals separated by commas and then with the square brackets. In this case, the compiler should be able to infer that the array is of type that names is an array of type strings. However, in this case, we are explicitly specifying the type. Here's the same example where we are allowing the compiler to infer that names is an array of string, and the compiler will do this successfully. Here, we're creating an array of integers. We have the square brackets, we have a list of integers separated by commas. The compiler will infer the new variable numbers to be of type int, or integer, actually an array of integers, an array of int. If we wanted a specific integer type, such as a int 8, then we would need to explicitly specify that type. Here's an example where we're using the same array literal to initialize our array. However, we are specifying that it is an array of int 8. So each integer is 8 bits, which means that the maximum positive value would be 127, and the minimum negative value would be negative 128 for each of the integers in the array. If you have an array, then you can use the contains function to determine if the array has a particular member. In this case, we use numbers.contains5 to test whether the numbers array has the integer 5. And it does, so this will return true, and then the code inside these brackets is executed. In order to use the contains function, the array must be of a type which conforms to the equatable protocol, because the contains function needs to be able to use to determine if the value passed in the parentheses equals one of the values in the array. Here are three different ways to initialize an empty array of type integer. In the first, we just use the square brackets. However, the compiler is not able to infer what type we have inside this empty array, and so we have to explicitly specify the type using the square brackets and then the integer. Here's another way of specifying the type. It's actually the array type, and then the array has internally it contains the type integer. This is actually the native way to specify an array of int. However, people don't typically do this. Another way is to use the initializer for the array of integers. So here we have the array of integer type, and then we're using the initializer to create the empty array, and then we're assigning the empty array to my array. In this case, the compiler is able to infer that my array is of type array of integer because we're using the array of integer initializer. Here are some examples of working with arrays. In the first example, we're creating a new variable myArray, and we're using an initializer to create an array of integers. This specific initializer, the first parameter is repeating, and we pass it in a value of 0, and then the second parameter is named count, and we pass it in a value of 100. This will initialize a new array of integer where it repeats the integer 0 100 times and then assigns that to my array, which is of type array of integer. Here we create a new integer, not an array of integers, just an integer, using the count property on myArray. So myArray.count will return 100 because my array has 100 elements in the array. Here we use the isEmpty computed property on my array. If my array is empty, then we will execute this code. However, my array has 100 elements, so my array is not empty, so this will return false. The isEmpty returns a Boolean, so it is always either true or false, as you would expect. Here we would create a variable array names. Names is of type array of string, and we give it 3 elements. Then here we assign the first element to our new constant first name. First name is of type string. We assign the first element using an array indexing. We give it the value 0 because in Swift arrays are indexed starting at 0. So even though this has 3 elements, the first element is element 0, and then element 1, and then element 2. And then we can print it out, and you can see that Anne was printed out. We can use this for assignment as well. In this case, names 1, we're giving it the value of Paul. Well, names 1 is actually the second element of the array, so Gary will be replaced with Paul. And then you can see we can actually print out an entire array, and it will print out the array in array format. And you can see that the array is now Anne, Paul, Keith. So the second element, which is indexed at 1, was replaced. It used to be Gary, and it is now Paul. The more precise term for this syntax is subscripting syntax. In addition, keep in mind that if you attempt to access an index that does not exist, for example, if we attempted to access names 3, well, names 3 does not exist. Element 0, element 1, element 2, well, element 3 does not exist. If we attempted to access names 3, then our code would crash. Here we have an array names with a single element of type string, and then we can use the append method to add a second element, and we can even use the plus equals syntax to append 2 more elements, resulting in an array of 4 elements. We could even append an array to an array. Here we have an array of 4 elements, and we can insert a new element at any index that we want. In this case, we insert at index 0, which puts the new element before the current index 0 element, resulting in an array of 5 elements, starting with our new element Bob. We could even insert an array. In this case, we're inserting a single string into the array of strings, but we could insert an array of strings into the array of strings, basically concatenating the 2 strings together. Here we have an array of 4 strings. We can remove an element at a specific index. In this case, we're removing at index 2, which means we will remove the 3rd element. When we remove the 3rd element, in addition to reducing the size of our array down to 3 elements, the value is returned. And in this case, we're initializing a new constant Chelsea, which is of type string, with the value of the string that was at the element number subscript number 2 in the array. We can also use the remove last method to remove the last element. That would remove, in this case, Dan, because that's the last element in the array, and it returns that. So if we want, we can assign, in addition to removing it from the array, we can assign it to a new constant as we do here. And then we print out our remaining array. We have 2 elements remaining. We could use a remove all method, which removes every element of the array, resulting in an empty array. And then we print out the empty array, and you can see here is our empty array. It's still of type string. It's still type array of strings, but it has no elements. We can add 2 arrays together as long as they are of the same type. And in this case, we're creating a new array, and the compiler will infer that the new array is of the same type as the other 2 arrays. We can have arrays within arrays. Here, array 1 is of type array of int. Array 2 is also of type array of int. Here we have a container array, and the container array is an array of arrays of type int. So then we could take out the first array using the subscript syntax. So first array will be what was the first element of the container array, which is this array up here, array 1, 2, 3. We can get the first element, which is the first member of container array, and then the first member of that, which would be 1. And then we can print all of these out. So we print out container array, and you can see we have an array of 2 elements, and each of the elements is an array of 3 elements. We print out first array, and it's an array of 3 elements, and we print out first element, and it's just an integer. A dictionary is a very powerful data type where you have keys and values. Here we use a dictionary literal to initialize a dictionary. The dictionary is a variable of we named it scores, and it is a type of dictionary of string to integer. So each key is a string and each value is an integer, and we have 3 of those key value pairs. Here's a way to instantiate an empty dictionary of type string to integer, and we're using the type. We use the square brackets, and then we have the type, and then a colon, and then the value type. So the key type, and then a colon, and then the value type. And then we're using the empty initializer, which will result in an empty dictionary of this type. Here is the native type, where we have dictionary, and then we use the less than sign and greater than sign with the key type and then the value type in there. And then in this case, we actually have the empty initializer, so we initialize an empty dictionary of this type. And then here is an empty dictionary literal, where we have the left bracket, colon, right bracket, that initializes an empty dictionary. However, the compiler cannot infer the type of dictionary from this literal, so in this case we have to explicitly specify the type to the compiler, and again it is of type string to integer. Here are 2 ways to add new values to a dictionary. First, we create our dictionary with our dictionary literal, and then we're going to add a new value where the key is oli and the value is 399. Keys in dictionaries are unique, so if oli already existed, then we would update its value with 399. However, the key oli does not exist, so instead we will add a new 4th element to this dictionary, where the key is oli and the value is 399. Another way to add a new value is using the update value method. When you do update value, you give it the new value, and then the second parameter has a name for key, and you put in the key. In this case, the key Richard is already there, so the existing value of 500 will be replaced with 100. And in addition, update value will return the old value into and you can assign it to a constant or a variable if you wish. When you do the update value, if the prior key did not exist, then it would create a new key value pair, and the value that is returned, because there was no old value, it would be nil. So as a result, in this case, old value is a type optional integer, because the value of the dictionary is, the keys is string, the value is integer. However, we might return an integer if the prior key already existed. However, if the prior key did not exist, then we cannot return an integer. So as a result, old value is optional integer. Because update value is returning an optional int in this case for our string to integer dictionary, we can use the if-let syntax to conditionally put that optional integer into a definite integer. And if a value is actually returned, then and only then old value will get the integer value of the old value. In that case, it would be, in this case, 500 would be assigned to old value, and then this code would be conditionally executed, printing out Richard's old value was 500. If the old key did not exist, if the old key did not exist, then update value would return a nil, and if let old value would not be successful, and so nothing would go into old value and this code would not be executed. If we wanted, we could have an else clause, and then in the else clause we could print out that the Richard did not have an old value. We can remove an old value for a particular key by just setting its value to be nil. In this case, we are removing the value for the Richard key, which will result in our scores dictionary only having 2 key value pairs. We could also use the remove value for key method, and in that case, if it was success, it will return an optional value, and in this case we're using the if-let syntax so that if we remove the value for key loop, which we do in this case, then we will assign the old value of 400 to removed value and conditionally execute this code. Then we print out our dictionary. We started out with 3 key value pairs. We successfully removed 2 of them, resulting in a dictionary with 1 key value pair. Here we have a dictionary of type key is string and value is integer, and we have a .keys property which will return an array of all the keys in the dictionary. We also have a .values property which will return an array of all the values. So players is an array of string and points is an array of integers. We can also access a value by a key, and in fact this is the whole point of a dictionary. The whole point, we've been adding values, we've been deleting values. The whole point of the dictionary is to be able to access values. And so we look up a value by an index, which is the key. So we're able to look up the value, in this case our string to integer dictionary. We can look up a value with a string. Now this string might be there, or it might not be in the dictionary. So as a result, when we look it up, it will return an optional integer. And in this case, we use if-let syntax to unwrap the optional integer. And if the optional integer is not nil, then Luke's score will become an integer, and then this code will be conditionally executed. And in this case, it will print out 400. Here we try to access a value for the key Henry. Henry is not a key in our dictionary, so as a result it returns nil, and the if-let is not successful because in unwrapping an integer because it was nil, and so this code is not executed. If you are following along with the Apple curriculum, it is time to open up the collections playground and open and complete the exercises in the lab. This slide deck is published by Apple and is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.